our project, we analyzed the oscillating multifunction power tool from Harbor Freight Chicago Electric. Disassembling the power tool was fairly straightforward, as it only involved removing external screws from the handle and the headpiece. The connection between the head spindle and the motor shaft is a ball bearing that's offset from the rotating axis. The offset spinning ball bearing moves within a wishbone block that fits to the output spindle, so that as the shaft rotates, the ball bearing pulls the wishbone side to side to create the oscillating motion. At this point, we predicted that a critical component might be the ball bearing within the oscillating head, due to strong forces that constantly knock it back and forth. Upon removing the handle of the power tool, we got a good insight on the internal components. There's a large plastic bridge at the bottom that connects the external power switch to the internal power switch, as well as carbon brushes that are a requirement for the function of the DC motor. Both of these seemed like possible failure components. The variable speed controller is a simple circuit that just controls the power delivered to the motor. When looking at the DC motor, you can also see the contact that the carbon brushes makes with the motor. After using a tachometer to measure the tool speed, we found these results for the 6 variable speeds. The manufacturer's advertised speeds is anywhere between 10,000 and 20,000 oscillations per minute, which matches well with our results. Upon using the tool to cut a sample piece of wood, we found that it actually performs rather well and cuts very smoothly. However, when cutting from certain angles, sometimes the tool tends to push itself out from the cutting sample. Switching out the many variable heads of the oscillating power tool involved quite a lot of work and wasn't very streamlined. We didn't see this initially, but after reading a lot of online reviews, we actually found that the little collet stubs on the very end of the headpiece that connected to the variable head mounts actually become worn down and fail fairly commonly. We immediately saw this as a way of improving the design for future use. Also, hand tightening the screw and using an Allen wrench provides a lot of possible for stripping the screw and just causing another mode of failure.